So now that we've gone over some radicals and perfect squares, we can do some operations with those numbers. So example 7, we have 3 times, that's multiplication in between, the square root of 48. Now, we can't just multiply the 3 and the 48 together because one is underneath a radical, a square root, and the other one is not. So what we're going to do is we are going to try to reduce the radical. Anytime you have radicals to reduce, you start there. So we want to see what numbers fit into 48? 4, 9, 16, 25. You want to find the biggest one. 16 is the biggest one that fits in, and it fits in 3 times. Now we don't want to forget about this 3 outside. That's going to stay out in front of the whole problem. Now the square root of 16 is 4, so that becomes a 4. And then bring down your square root of 3, and you still have that 3 out front, which is going to come down. And then what happens between the 3 and the 4? Well, that's going to be multiplication. So we'll go ahead, now that they're both considered like terms and they're both out in front of the radical, we can multiply 3 times 4 and get 12 times the square root of 3. And that's our simplified answer. All right, example 8, we have some addition within a radical. So you can't square root these two numbers separately. You want to see if you can do any combining on the inside. So this problem has a little bit of simplifying. 6 squared is 36, plus 8 squared is 64. And now 36 plus 64 is 100. And now that we have it simplified down to one number, let's see if we know the square root of 100, which we do, we get 10. All right, so next one, we have 2/3 times the square root of 48. Well, the square root of 48, we already simplified over here. We know it's 4 times the square root of 3 because you can break it down into 16 and 3. So I'm going to go ahead and just say that's 4 square root of 3 because we already did the work before. And then we have 2/3 down out front times 4 times the square root of 3. So we can go ahead and multiply these numbers, the fraction and the 4. I went ahead and made a 4 a fraction by putting a 1 underneath. You can multiply across the top. 2 times 4 is 8. 3 times 1 is 3. So we have 8/3, and then that square root of 3, because we didn't have any other square roots to multiply with, just stays as 8/3 times the square root of 3. All right, example 10, we have some addition within a radical, so you want to add those first. 3 plus 6 is 9, so it stays underneath the radical, and then the square root of 9 is equal to 3. All right, example 11, this one is going to be probably less common than what we've seen before. If you notice, or not less common, but you did it last year in algebra, but I don't know if you did a ton of it in algebra. Do you see how we have the square root of 2 in the denominator? This is not good. We can't have a radical in the denominator of a fraction. So what we do is we do this thing called rationalize. I'll write it down here. Rationalize. We rationalize the denominator. So what that means is you take the denominator and you multiply it by itself. But if you're going to multiply the bottom times the square root of 2, you have to multiply the top by the square root of 2 so we don't change the value of our fraction. So this becomes 8 times the square root of 2 on top. And then on the bottom, the square root of 2 times the square root of 2, because they both have square roots, you can multiply these together. You multiply the 2 times 2 and you get 4, and it stays underneath the square root. So we're looking at the square root of 4. Well, that's a nice one because the square root of 4 is 2. And so that becomes a 2 in the denominator. Now, is this answer simplified enough? Well, see how you have a square root of 2 over a 2? You can't do any reducing with those because one is underneath a radical and one is not. But you do have this 8 and this 2 over here. You can go ahead and divide those. 8 divided by 2 is 4, and then the square root of 2 just stays. So we have 4 square roots of 2. All right, so let's try that rationalizing again. We have 6 over the square root of 3, so to get rid of the radical in the denominator, we rationalize it, multiply it by itself. All right, so the top becomes 6 times the square root of 3. The bottom becomes the square root of 3 times the square root of 3, the square root of 9, which becomes 3. Now look to see if you can do any reducing with these outside numbers, and by outside, I mean they are outside of the radical. 6 divided by 3 is 2, and then the square root of 3 stays. So we have 2 square roots of 3. All right, these last two examples have to do with adding and subtracting radicals. So when you're adding and subtracting radicals, you want to think about like terms. Just like, an x can only be added with an x, a radical can only be added with the exact same radical. So do you see how this has a square root of 5? This is a square root of 3, square root of 3, square root of 5. So what I'm going to do is I'm going to combine these square roots of 5 together because those are like terms. Because they both have a square root of 5, those go together. Then all that you do is you look at the number out front, kind of like a coefficient in front of a variable. You have a 7 square roots of 5 minus 2 square roots of 5. 7 minus 2 is 5, and the square root of 5 stays exactly the same. So we took this 7 minus 2 and got 5 square roots of 5. All right, then we have a negative 2 square root of 3 plus a 3 square root of 3. So because those are both square roots of 3, we can put those together and then look at the numbers out front. You have negative 2 plus 3, which gives you a positive 1, and then square root of 3. Now that 1 is optional. You can say 5 square roots of 3 plus 1 square root of 3, which is just the same thing as a square root of 3. I would take either answer. All right, so example 14, I can see we're adding and subtracting radicals, and it's tempting to just go ahead and take 32 minus 18 plus 75. These are not like terms in the current state that they are in. We want to reduce these radicals so the problem looks more like the one over here, and then we can see if we have any of those that can go together. So again, reducing your radical, we're looking for the biggest perfect square that fits into 32, and that's going to be 16 times 2, so this becomes a 4 square root of 2, minus, because there's a minus up there, now we've got 18. What perfect square fits into 18? That's going to be 9 and 2. So square root of 9 is 3, and then the square root of 2 stays. And then 75, that can break down into 25 times 3. And the square root of 25 is 5. I'm going to bring down the plus. Square root of 25 is 5, and then square root of 3. So now that we have simplified radicals, we can see which ones will go together. So I see a square root of 2 here and a square root of 2. This one has a square root of 3, so that's not a like term with these. So we're going to go ahead and combine these. We got 4 square roots of 2 minus 3 square roots of 2. So 4 minus 3 is 1, and then the square root of 2 stays, and then plus 5 square roots of 3 because we couldn't do anything else with that. Now again, that 1 is optional, so if you prefer to write it square root of 2 plus the 5 square roots of 3, that would be correct as well.